Okay guys, so today's problem is to find the local minimum element from the matrix. The matrix is of n by n size. We have to find the local minimum element from this matrix. So basically the local minimum element is the element with the less weight than its neighbor. Like for example, 1 is the local minimum element since its neighbors are left, right, up, down. So we have to compare only left, right and up, down elements with this middle element, not this diagonal element. So 1 is the local minimum element since its weight is less than these neighbors. One, one here is also the local minimum element. So the basic observation is there might be more than one local minimum elements in the given matrix. The global minimum element is a different one. It's a different concept. So it's a our problem is to solve is to find the local minimum element from the given matrix. Then the challenging part is so there are a couple of algorithms which are available to solve this problem. But the challenging part is to solve this problem using big of n time complexity. So there is this algorithm available to solve this problem using this time complexity. So the basic algorithm is we have to traverse the middlemost column and middlemost row to find the minimum element. So first we traverse the middlemost row and middlemost column and middlemost row. So the minimum element from these many elements is 11 since it is lesser than all these elements. So first we have to take this element and then check its neighbors. So these are its neighbors, right? So since this is the smallest element among all of its neighbors, this is the middlemost element, this is the local minimum element. For example, there is this element here. So in this case our algorithm is same. First we traverse the middlemost column and middlemost row to find the minimum element. So here it's 11 again. Then we check the neighbors of the 11, which are 3, 15 and 175. Then we pick the smallest neighbor among these three neighbors, which is 3 here, right? So same algorithm works on this quadrant now, this quadrant. We have to run the same algorithm in this quadrant. So here the middlemost row and middlemost column is this one, because it's a like 0 1 first row and first row and first column, so it's the middlemost column. So this is the middlemost column. We have to find the minimum element from this row and column. So it's 3 here, right? Then we find the smallest number of 3, which is 123 and 2. So 2 is the smallest number. Then we run the same algorithm to this quadrant only. In this case the row and column is the same, so it's 2 only. So we check the 2 with its neighbors, which are 145 and 3, but since 2 is less than both of its neighbors, 2 is the local minimum element.